Okay, you cannot assume that the triangles are similar. Okay, it says you have to prove that it's similar. You have to demonstrate that it's similar. It doesn't mean that you can make that assumption that it's similar. So I'm seeing a lot of people saying, well, FE over BC is equal to AF over AB. Well, that's equal to AE over AC. You can't assume this to prove that it's a similar triangle. You can't assume what you're proving to prove it. Right? Like I can't assume that you're smart and I'm going to prove that you're smart. You have to have evidence to prove this, then I can assume it. I have to prove that you're smart, then I can assume that you're smart. Right? So you have to prove that these triangles are similar. So I gave you all the lengths. Then you've demonstrated in the past it would prove that it's similar. Right? So the question is, how do I prove that it's similar? And then we can start doing this to solve all the lengths and all the angles.
First, we can say that both of them have one angle that is 59.
Good. So we see that there's one similarity here that both triangles have one angle of 59 degrees. So given that what we learned about similar triangles, what three situations can we demonstrate to prove that two triangles are similar? Zach?
The sides are the same proportion.
Yeah, so one is all the sides are all proportional. Here we're not given all the lengths of the sides. So we can't use that. Right? What's another way that we can demonstrate or show that two triangles are similar? Tyler? All angles are the same. So we only know that really two of the angles are the same. I haven't shown you that angle E here is 90 degrees, so you can't assume that. Pardon?
Why not?
Because I haven't indicated as such.
Could be 91 degrees.
It could be 90.000001 degree.
I don't know.
Okay? So unless I indicated that's a perfect right angle, you cannot assume that. So we can't use the angles because we don't know the angles of all triangles. Alright?
It says two sides are the same proportion and included angles. So did you use the a squared plus b squared plus c squared to find on the other side?
Yes, we know that this angle ABC is a right angle triangle. That we do know. But we're given two of the sides. Right? So can we at least calculate the third side?
Yeah.
And how do we calculate the third side here? What equation, what formula did we use to calculate the third side? Zach? Pythagorean theorem, right? So we take the square over two shorter sides. So that's this squared. And so 3 squared is 9. Put that in brackets. And we add those up. So what do we get? 34. And we take the square root of that to get the length of the third side. So at least now we know all the lengths of one of the triangles, a smaller triangle, ABC. Right? But how can we still prove that the two triangles are similar? How can we prove that the two triangles are similar now? Eric? Yeah.
You must find EA.
You must find EA.
Because you know the ratios between the other side to
Yeah.
Okay, well we can't find EA because we have no tools,
Yeah.
right, to find the EA. I know, we all play NHL 13, like my son, whenever wears EA. Okay, so we can't quite get EA yet.
Yeah.
But let's go back to the other question of how can we prove that these two triangles are similar? Alicia.
Because since you found that one's square root of 34, and then the other one is 2 times it, and then you can BC is 3, and the other one is 2 times it.
Okay, so what was that? What was that third way that we could prove the two triangles are similar?
Side one.
Right? So if we have the same angle, right? And the sides on both sides of that angle are proportional. So let's go over here, erase this, and we say that EF over FA, what is that? So that's 6 over 2 root 34. That gives me 3 over root 34. Right? So you see how I simplify that ratio? Right? So I just took the ratio of this length over this length. I'm going to do that for the other triangle. So I have BC all over AB, which gives me 3 over root 34. So my two ratios are the same. So because those two ratios are the same, and I have my angle in between that's the same, that's how I've proven that these are two similar triangles. Okay? So the key was getting this.
You have to get like a column.
Yeah. You have to get that other side and determine that those two ratios are the same. Okay. So now that we got this, then now we can safely assume that, well, basically this is twice the size of that triangle, that this is length 10. What can we assume about this angle now? It's 90 degrees. So we can safely assume that now because they're similar triangles. And then finally, what's the two angles left over? What are those angles?
31.
And how do you get 31?
You add 59 and 90, and then subtract it from 180.
Yeah, so basically we know that three angles in a triangle add up to 180. So 180 minus 90 gives us 90, minus 59 gives us 31. Okay, so that's how you can solve for that triangle, once we've proven that they're similar. Any questions on that? I purposely chose the harder of the three in proving the similar triangles. You had lots of practice with the other two. This one's a little more difficult. Okay?
Can I take a picture of it?
Okay, so new question. Going back to grade 9. So I'm going to graph y is equal to 2/3 x. I'm going to graph this in our head.
I thought you said I.
No, you will graph y equals 2/3 x. Okay, we can make a graph of decent size. So it takes us back to unit 1, where we're solving the system equations. Okay, hopefully your graph will look something like that. Right? A y-intercept is 0. Right? So it just goes through an origin. And my slope is 2/3. So up to over 3, there's 1 point. Up to over 3, there's another point.
Overthinking the question.
You're overthinking.
Overthinking math.
I thought it was.
Math is
I
nothing to
didn't
do with
think
thought.
it was gonna be that easy.
I start us off easy, right? Build ourselves up.
Wait, which one's the slope?
So this was our slope,
You just gave us the slope.
right? The coefficient in front of the x.
The A, right?
Y equals mx plus b. Maybe you didn't see my grade 9 classes right now, because that's what I'm teaching. Y equals mx plus b.
Yeah, surprised I don't know it.
We did this in unit 1, we had to graph lines. Oh boy, I see our final exam is gonna be a challenge.
About parabolas.
So there's a slope, so there's a line. Okay? So I'm gonna do something interesting with this line now. Zach, you take all the fun out of what I'm doing. What?
You didn't hear that, so it's gonna be more fun now.
Oh, I
Okay,
see,
yeah.
I see how this.
So I'm gonna do this.
Freaking.
I'm gonna make that a triangle on that line. Okay, although you can kind of see that.
Is this how you used to
I don't know why I'm pressing hard on this thing, like it's gonna get darker. Okay, so there's my triangle. So basically I'm using my slope of the line itself, and I'm using the x and y axes for going up and down, straight up and down from there, up and across, right, to form my triangle. So without taking on any calculators and anything, who could give me 2 lengths of that triangle right off the bat? What are the lengths of? Sean? 3. Okay, which one's 3? Which one's 2?
The bottom one's free.
So here's 3, and this one's 2, right? We have lengths 2 and 3.
Oh, that's what you do.
I'm not doing anything.
But I know what I'm thinking.
Stop making fun, Sean.
Okay? I'm gonna create another triangle. This one's blue. I'm gonna create this triangle over here.
What if my thing doesn't go that far?
Extend a little bit then.
Yeah, we don't have 2 colors.
Okay? First of all, I can assume that these are right angles in here. Right? Because in our grid, we form exactly right angles. So who would give me the lengths of the size of the 2 lengths of this triangle? Yeah.
Okay, why can you assume that that one's a right angle, but on the other question you could just assume.
This one, because we're doing directly 90 degrees this way and this way. We're doing perpendicular with the x and y axis. Right? That's how we formed our triangle based on the fact that's 90 degrees there. Okay?
The small hypotenuse side, the small triangle is 3 points.
We're not going to worry about that. In fact, it doesn't really matter for now. But thank you for that information. In fact, the smaller one, we want to say it's the square root of 13. 9 and 4. You don't want, I don't want a decimal answer for now. It's the square root of 13.
Oh.
Let's see.
Do you want
So
that
what's the
one?
length of the two other triangles?
4, 6 of
Nick?
6 on the bottom, 4 on the right.
Okay. Are these two triangles similar?
Yeah.
Obviously, but mathematically tell me why they're similar.
They have the same angle.
Yeah?
There's some proportion.
Okay, well let's say I didn't know a squared plus b squared equals c squared, and I couldn't calculate the hypotenuse. How else can we just prove that these two triangles are similar? John?
You divide the larger triangle, both sides, divide by 2 equals the smaller one. So if you
Divide 4 into 2 into 4? Okay, not quite. We don't want ratios, we can't do anything with the ratios between these sides here because we don't know all the sides. Rachel?
The small one is a part of the bigger one. It's like inside the other one.
Okay, but that doesn't necessarily prove it to us.
oh they have the same angle.
Okay, go back to what we just did in the previous exercise. Tyler?
There's two side lengths that are proportionate.
Right. Yeah, so we take this side length, right, 2 over 3, and here it's 6 over 4,
Yeah.
which equals 2/3. I mean, we know these ratios are going to be the same. Why is that? Oh, sorry, 4 over 6. Right? We know these ratios are going to be the same. Because this is just what? They're just our slope. Right? We know those ratios. Rise, I mean, we look at the opposite side, really just our rise. Right? We look at here, this is just our rise, and this part is just our run. We know that ratio is always going to be the same. It's our slope. Right? The angle in between is 90 degrees. Same angle. Ratios of those sides are the same, so we know that these are similar triangles. So taking that one triangle, I want to make it a little bit bigger. So I'll just draw another triangle if you want. Okay, so this would have been the third triangle that we're drawing. If I drew another triangle here in red, this would have been this red triangle. Right, or this is 6, this is 9. Okay, so I have 9 and 6, that's the length of our the length of the two sides of our triangle. Now I'm going to start learning some Greek.
I heard that's pretty difficult.
Okay, Greek letters.
Oh,
This symbol, which is the best I can find on here, is really written like this. Theta. It's pronounced theta. Actually, this is supposed to be T, right?
Yeah,
Does it only go to one
Theta.
side?
It's pronounced theta. Yeah, theta. Theta. So it looks like a little lowercase o almost, but the line's all the way across.
music.
So theta is referred to the slope angle. Okay, which is opposite of the rise. So here's our rise. Right, so it's opposite of the rise. And adjacent to the run. So here's our run. Sorry. If we notice back in that old diagram, it was that theta was the same angle for all the triangles. So I want to clarify a little bit about the terms of opposite and adjacent. Okay? So when we look at this angle theta, we'll look at not the angles, but the sides. So what is the side that's opposite of theta? Well, we don't want to talk about the hypotenuse yet, because we're just talking about rise and run. Okay, the shorter lengths of the triangle. So the opposite is, just think of English, right? It's the one that's kind of like on the other side, right? The anti-hero, is that what you said? So it's the villain?
Yeah.
Okay. So I think about the opposite is really the rise, or the side that's the farthest away from your angle. Adjacent is the side that's closest to your angle, but it's not the hypotenuse. Okay? So what we have is that tan of theta is the ratio of the opposite side to the adjacent side in a right angle triangle. So we define this term tangent. Right? Tangent of theta is the ratio, right? We just saw it, it's like the slope almost. Ratio of the opposite side over the adjacent side. So here in this example, tan of theta, so that's how we write that. Tan. Camel?
What?
It's tan though. Tan. Although I have to call Mr. Tan, not Mr. Tan.
Is that tan? Like,
Tan. But this is tan, like what you would get in the summer. Tan of theta is opposite over adjacent. So we abbreviate that over O over A. In this case, we have 6 over 9, this is over 2/3. So tan of theta is 2/3. Okay?
What's the final?
Sorry, what's the
What's
what?
the final 2 over 3 called?
That's just the tan of theta. That's the ratio. Okay? Any questions on this?
in other words, slope.
We could look at it as a slope in this way, yes. Okay, everybody good with this? Tan of theta, the tangent of this angle, is the ratio of opposite over adjacent. Okay? It is, well, you'll see in your calculator, it is a function as well. We'll see that. Okay?
What hands are here? Eight. How would you enter it on your calculator? Is with the 10. Just do 6 over 9.
We'll talk about that later.
That's fine.
Okay? So now what we want to do is we just want to solve for this triangle now. In other words, we want all the angles. Well, this length is pretty easy. How can we calculate the length, this length? No, that's a right angle triangle. So it's the Pythagorean theorem. So what we're going to do, we're going to square this side. So 9 squared is equal to 81. 6 squared is equal to 36. So here we have 9 squared plus 6 squared is equal to 81 plus 36. What is that? 117. So we need the square root of that. So that length is the square root of 117.
Okay, is that a C on the right? So 6.
That's 6, sorry, this is 6. How do we get the angles though?
Would you have to simplify that?
Can you simplify
It's
that?
divided by 9, isn't it? It's 313. Should be 313.
Can you simplify something?
Yeah, it's 3.
Is it 3?
Yeah, it's 313.
Thank you. So this is
Oh, that weird.
so this is same as 9 times what?
It's
9 times 3?
it's 3 times
9
3
times
times
13.
13. Yeah.
So that's equal to 3 root 13. Thank you, Eric. Yeah, so don't forget to simplify your radicals.
We always have.
Yes. Else you lose technical marks. And I know how much we hate to lose technical marks.
I know.
Not the technical mark thing, I know. You guys get dot mark for spelling? Mistakes? In English?
Yeah. In history, it's
In
more
history? So good.
Spell checks for us, huh?
So the question is, how do we solve for theta? How do we get this angle? Well, what do we know? We know tan of theta is what?
Over
6 over 9, 2/3, which is same as 2/3. So we want to solve for theta. Right, what does solving for an equation mean again?
Isolating the variables.
Isolating the variable. Great math terms. Isolating a variable, getting the variable by itself. What purpose does that serve?
If one of the variables
That what?
that suits the.
Thank you. That makes the equation true. That makes our equation true. Okay? So in order to isolate for theta here, we have to do the opposite of tan. Right? Which is what we call the inverse of tan. And it's written like tan to the power of -1. Right? Or it's the inverse of tan. The tan theta. So we need to take the inverse tan.
Bless you.
I just thought of a weird joke, but I'm not sure if it will fly.
Let's do it.
If it will fly?
Yeah. So the inverse of tan is bleaching yourself? I don't know. The inverse of tan is bleach?
Aha.
It's not happening.
I know, that's why I'm not sure it will fly or not.
Still all shakes.
So what we want to do is take the inverse of tan. So here you can see that sort of like it's like taking the square root of a square, right? We're doing the opposite of square here, we're doing the opposite of tan. So that just leaves us with theta. Question is, how do you do the inverse of tan of 2/3? So you're gonna need your calculators. Are you confused on Sabrina?
33
We're
points.
gonna talk about it now.
34, Mr. Tan.
Why need a scientific calculator?
Yeah, you need
So take out your calculator. You will need a calculator for this unit. Yes. Yeah, so it's opposite over adjacent, which is 6 over 9. So reduce it to 2/3. So depending on your calculator, you either have to do 2 divided by 3 first to get like 0.6666. And then every calculator has a tan button. You have to do like shift
That's right.
tan. In other words, if you look at your calculator, you see tan, and above it you should have like tan minus 1.
Oh, yeah.
Is there a value to tan?
Oh, I have.
Is there a value to tan?
Is it like a pi button?
Pardon?
I don't understand.
Just understand what tan of a tan of an angle means. It's just that
Yeah,
ratio.
you don't have to know what it is. You have to know how to find it.
Look at that.
Sorry? 34 what?
33.6.
So is it like 34?
So we'll say 34 degrees.
That's 33.69.
What is it? 33.96?
69.
So what is it?
This is the solve.
Okay,
Do,
Big question.
so we're taking, so did everybody find out in the calculator, inverse tan function? So if you do the inverse tan of 2 divided by 3, which is 0.6666 repeated, you should get an answer roughly around 33.69. That tells you the degrees. That tells you the value of your angle. So now we know that theta is equal to 34 degrees. Okay.
That's not my fault. Actually, it kind of was.
I like our first natural instinct is to lie. Not my fault. I just threw it on the ground, but it wasn't my fault.
What is the squiggly line?
This squiggly line is approximately.
When did you feel it?
Actually, you guys are probably maybe used to seeing it this way. Equal to the dot on top?
Yeah.
That's approximately.
Is it approximately 40? Is it approximately 34?
Yeah.
Sorry?
34.
Oh, sorry.
34. I was like, 7 is half.
I know right there.
Lunch.
yes.
Okay. So humor me, and take 34 and you calculate do tan of 34. What do you get? Amanda, you calculator take tan of 34.
If I wanted to be how I
0.67.
Error.
Daily.
I'm really clumsy though.
So now I'm do tan of 34. Your calculator.
So who gets to answer first one? You're taking time. 1 plus 1.
This calculator is 34.
My calculator has fancy here.
So what answer did you get?
0.67.
Okay, so you get roughly almost 0.666. If you do tan of this number, 33.69, you'll get closer to 0.6666. Okay, so what that tells you is that when the tan function, what it is, if you give it the angle, the tangent of the angle will give you this ratio of opposite over adjacent. Okay, because we understand that for all triangles, if we have this angle 34, your ratio of opposite over adjacent will always be the same through the similar triangles. So that's what the tan function does. It gives you the ratio, given a degree, in a right angle triangle, what that ratio is in opposite side over your adjacent. It doesn't give you the actual side lengths, because we don't know that any of the side lengths, but it gives you that ratio, it gives you that proportion. Okay? So any questions on that? Might be a little bit confusing. I know it's the first time we introduced the trig function. That's what tangent is, right? Basically, if you're doing tan of an angle, it just gives you that ratio of the opposite side over your adjacent side. Gives you that fraction. Gives you that decimal. Okay? Doing the inverse of it will give you an angle. Alright? Does everybody have these two notes now? I started to change my notes a little bit with the star asterisk. Those are the key concepts that you gotta make sure you understand from the lesson. Okay? The star exclamation marks. Okay, can I move on to the next one? Now we want to solve this triangle. Okay, scrap this. I've got to delete it. And yes, I didn't have time to put in this symbol. That's a right angle triangle. Not assume, it needs to be told. So how can we solve this triangle? This is really weird now because we're only given one side and one angle.
No, not really. Still fine.
Well, we know that the tan of an angle is opposite over adjacent. So in this triangle, which is compared to 35, which is the opposite side? I see pointing. Serena, what's the opposite side to this 35 degrees? This? What side is opposite this angle?
What are you doing?
There's no real name, just point me which side.
Is our vertical side or the horizontal side?
Or this side. There are those three sides of the triangle.
Hypotenuse.
So which side of the triangle is opposite this angle?
Okay.
Never.
This one? This one here?
Just choose
No,
one.
that
Just choose one.
is it the one on the bottom? No, it's hypotenuse.
Opposite. So the one that's farthest away from the angle.
Hypotenuse.
Hypotenuse is the
You don't
C
use
squared
hypotenuse.
Twenty.
So you're saying that this is the opposite?
Take a guess.
20.
Right? This is the opposite length. So that's your opposite side. It's the side that's farthest away from the angle. Okay? I think opposite, the villain, anti-hero, right? Farthest away from the angle. Okay? So which one is the adjacent? The horizontal one. So this one here, adjacent one, because we know that one's our hypotenuse. Okay? The hypotenuse just keeps a special name, hypotenuse. Okay. So do we know our angle?
We can find that angle up there.
Yeah, it's
We can find that angle on the top.
Yeah, well, we can easily find this angle, right? But we'll talk about that later. Okay. Do we know the angle that we're looking at? 35. So the tangent of 35 is,
Well, I got you.
what's the opposite? What's the opposite side? What's the length of the opposite side? 20? And then what's the length of our adjacent side? A, we don't know.
Hey,
Okay.
stop being Canadian.
Love being Canadian.
H, not A, it's not
Okay.
adjacent.
You solve for adjacent.
So now how can I solve for A? Look, we just want to solve for A.
You put 20 over on the other side.
Well, I'm basically going to multiply both sides by A.
I would say the letter.
So I got A times
What's the letter A?
tan of 35
CH.
to 20. And then you divide by tan of 35. So A is equal to 20 over tan of 35.
29 days.
So what do I get?
29 degrees.
It shouldn't be a degree.
Round up.
We're talking about length now.
You're out of line.
So 20 divided by tan of 35.
And it's
Yeah,
28.5, Matt.
28.5.
you get 6 actually, you're gonna round up, right?
28.5.
5 what? Well, we'll go to two decimal places.
I deleted it already.
5 7.
Yeah.
Okay. So no, this length is 28.57.
Why don't we just round it?
Well, it's not exact. We'll keep it to two decimal places. On a test, you'll be told how many decimal places to write into. So how can we solve for the rest of the triangle?
Yeah, dear.
A squared plus B squared.
Yeah. So here we're going to get h is equal to the square root of 20 squared plus 28.57 squared.
So,
Oh, what am I doing?
So who can calculate that for me?
the answer is 30.87.
34.87?
Then you can find the last angle. Oh, I thought you were on.
Okay, so for this last angle, okay, I have 5 minutes to try to finish this. It'll be 10, it'll be 15, I don't know. For the last angle, there's 2 ways we can solve this. The easiest way is what?
180 side is
The 180 rule, right? So 180 minus 90 is 90 minus 35 is 55. Okay? Let's just say that, humor me, I don't want to do it that way. We're going to call this angle another Greek alphabet called alpha. Like a little a. Almost like a little fishy. Okay? So here we have alpha.
Laugh at me.
So let me ask you this, what is the tan of alpha?
I don't know.
What is the tan of alpha?
So you should have.
A.
You don't need it.
So here, for alpha, what is the opposite side for alpha?
Alpha minus
28.
Yeah.
Oh, Sabrina's getting it.
So the opposite side of alpha is this side now, right? So it's all reference to the angle that you're looking at. So I'm trying to push you thinking beyond sort of like horizontal and vertical. But basically now we're looking at this angle up here, well the side opposite, side farthest away from it this time is 28.57. And what's the side that's adjacent to it? Okay, 30, that's the hypotenuse, we're going to keep it as a special name hypotenuse. So we're going to left with the other 2 sides. So it's a 20.
You don't really put the hypotenuse.
No. Well, you do, but you don't give it another name.
Okay.
Okay, this has the name hypotenuse. So take 28.57, divide by 20, and take the inverse tan of that. So alpha really is the inverse tan of 28.57 over 20.
55.
What do you get?
55.
55? For real?
Not on the.
Oh, sure.
55.00663388.
Yeah.
Nice.
So doing this matches up with what we thought with the 180-degree thing. Okay? So that's one trigonometry function is called tangent. That's when we're looking at an angle and seeing what the opposite side compared to its adjacent side. Right? Any questions on that? Kind of straightforward? Hopefully.
Good.
There's the homework.
Oh.